In a laboratory in Vienna, a physicist named Anton Zeilinger conducted an experiment that should be impossible. He fired single photons through a device that could detect which path each particle took. But here's where reality broke down. The moment he turned on the detector to observe the photons, they began behaving completely differently. Not just future photons, but photons that had already passed through the system, as if the act of observation reached backward through time to change what had already happened. Welcome to the quantum observer effect, where consciousness doesn't just witness reality, it actively creates it. Tonight we journey into the most mind-bending discovery in modern physics, a phenomenon so strange that Einstein called it spooky action at a distance, and refused to believe it could be real. But here's what will blow your mind. Recent experiments have proven Einstein wrong. The observer effect is not only real, it suggests something revolutionary about the nature of existence itself. Your consciousness, your awareness, your simple act of looking at the world might be the fundamental force that collapses infinite possibilities into the single reality you experience. I'm about to show you experimental evidence that challenges everything we thought we knew about the universe. We'll explore quantum experiments that demonstrate how observation literally shapes reality at the smallest scales. We'll examine the delayed choice quantum eraser experiment that proves consciousness can influence the past. And we'll dive into the philosophical implications that have left the world's leading physicists questioning whether reality exists at all without conscious observers. This isn't science fiction. This is cutting-edge quantum mechanics backed by decades of experimental data. And by the end of this investigation, you'll understand why some of the smartest people on Earth believe consciousness might be the most fundamental force in the universe. Now, prepare yourselves, we begin. But first, let me show you just how deep this rabbit hole goes. Picture the most famous experiment in quantum physics, the double-slit experiment. It seems simple enough. You fire particles like electrons or photons at a barrier with two slits cut into it. Behind the barrier sits a detection screen that shows where each particle lands. Basic physics says each particle should go through one slit or the other, creating two bands on the detection screen corresponding to the two openings. But that's not what happens. Instead, the particles create an interference pattern, multiple bands of light and dark that can only be explained if each individual particle somehow goes through both slits simultaneously, interfering with itself like a wave. Single particles behave as if they exist in multiple places at once, exploring every possible path through the apparatus before deciding where to land. This wave-particle duality baffled physicists for decades. How can a single particle be in multiple places at the same time? The answer seemed to lie in quantum superposition, the idea that quantum particles exist in all possible states simultaneously until something forces them to choose a specific outcome. But here's where it gets weird. The moment you try to observe which slit a particle goes through by placing a detector at one of the openings, the interference pattern disappears. The particles suddenly start behaving like normal particles, going through one slit or the other. The wave-like behavior vanishes the instant you try to measure it. The act of observation fundamentally changes the behavior of reality at the quantum scale. Dr. Thomas Young first demonstrated this phenomenon in 1801 using light waves, but when the experiment was repeated with individual particles in the 1970s and 80s, physicists discovered something that challenged the foundations of science itself. Reality at the quantum level appears to be fundamentally uncertain until the moment of observation. Think about what this means. Before measurement, a quantum particle exists in what physicists call a superposition of all possible states. It's not that we don't know which state it's in, it's actually in all possible states simultaneously. The particle is in a ghostly realm of pure possibility, neither here nor there, neither this nor that. Only when consciousness observes the system does this superposition collapse into a single definite outcome. but the implications stretch far beyond individual particles. If quantum mechanics governs the fundamental building blocks of matter and energy, and observation affects quantum behavior, then consciousness might play a role in shaping reality at every level of existence. This brings us to one of the most controversial interpretations in physics. The consciousness-based interpretation of quantum mechanics suggests that conscious observation is what causes the wave function to collapse. Without consciousness to observe it, the universe exists in a state of pure potential, a ghostly realm where nothing is definite. Most physicists resist this interpretation. They prefer explanations that don't require consciousness to play a special role. Decoherence theory suggests that interaction with the environment, not conscious observation, causes wave function collapse. The many worlds interpretation proposes that all possible outcomes occur simultaneously in parallel universes, and we only experience one branch. But recent experiments have made the consciousness interpretation harder to dismiss. In 2007, researchers at the University of Rochester conducted a delayed choice experiment that pushed the observer effect to its absolute limits. They created a setup where the decision to observe or not observe a photon's path could be made after the photon had already passed through the double-slit apparatus. Here's how it worked. A photon travels toward the double-slit barrier. After passing through the slits but before hitting the detection screen, the photon encounters a beam splitter that randomly sends it down one of two paths. At the end of each path sits a detector that can be turned on or off. The crucial element is timing. The decision to activate the detectors happens after the photon has already gone through the slits but before it reaches the final detection screen. If the detectors are off, the photon should create an interference pattern indicating it went through both slits. If the detectors are on, revealing path information, the interference pattern should disappear. The results were stunning. The choice to observe or not observe, made after the photon had already passed through the slits, determined whether it had behaved as a wave or particle earlier in its journey. The future observation appeared to retroactively determine the photon's past behavior. It's as if the universe remained undecided about what had happened until consciousness made the choice to look. Dr. John Wheeler, who designed this thought experiment, called it a delayed choice quantum eraser. The name reflects its most unsettling property. The act of measurement doesn't just reveal information about a quantum system, it can apparently erase or create that information retroactively, but the implications go even deeper when we examine what happens at the moment of measurement itself. Quantum mechanics describes measurement as a discontinuous, instantaneous process. One moment the particle exists in superposition, the next moment it has definite properties. This transition, called wave function collapse, happens faster than light could travel across the system being measured. Einstein objected to this non-local aspect of quantum mechanics, arguing that it violated special relativity's prohibition against faster-than-light communication. He proposed that quantum mechanics must be incomplete, hiding variables that would restore deterministic behavior if we could access them. But Bell's theorem, proven mathematically in 1964 and confirmed experimentally countless times since, demonstrates that no hidden variable theory can reproduce quantum mechanical predictions. The correlations observed in quantum experiments are stronger than any classical theory allows. This means the observer effect represents a genuine feature of reality, not a limitation of our knowledge. Recent experiments have pushed these conclusions to their logical extreme. In 2019, researchers at Yale University created a quantum system where they could monitor the gradual collapse of a wave function in real time. Using superconducting circuits cooled to near absolute zero, they watched individual quantum jumps as particles transitioned between energy states. The shocking discovery was that these quantum jumps aren't truly random or instantaneous. They're predictable and take measurable amounts of time. More importantly, they can be interrupted mid-jump by clever manipulation of the measurement process. The researchers could literally catch a particle in the middle of changing states and reverse the process, forcing it back to its original condition. It's as if they gained the ability to rewind quantum reality itself. Dr. Zlatko Minev, who led the experiment, described it as being able to predict and reverse the fate of Schrödinger's cat. the famous thought experiment where a cat exists in superposition, simultaneously alive and dead, until observation collapses the wave function. These results suggest that consciousness doesn't just passively observe quantum systems, it actively participates in determining their outcomes through the mechanism of measurement. But what exactly constitutes measurement in quantum mechanics? This question has puzzled physicists for nearly a century. The traditional Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg, treats measurement as a black box. Something happens when a quantum system interacts with a measuring device, but the theory doesn't specify what that something is. Measurement is simply defined as any interaction that produces definite outcomes from quantum superpositions. This circular definition works for calculating experimental predictions, but it doesn't explain why measurement has such a special role in quantum mechanics. Why should interacting with a measuring device be fundamentally different from any other type of interaction? Some physicists argue that measurement isn't special at all. Decoherence theory proposes that quantum superpositions are constantly being destroyed by interactions with the environment. What we call measurement is just one type of environmental interaction among many. But decoherence theory faces a critical problem. It can explain why we don't observe superpositions in everyday life, but it can't explain why specific outcomes are selected during measurement. The theory shows how quantum systems become entangled with their environment, but it doesn't explain why we experience one particular outcome rather than the ghostly mixture that quantum mechanics predicts. This brings us back to consciousness as a potential solution to the measurement problem. The consciousness-based interpretation suggests that conscious observation is qualitatively different from other types of interaction. When a conscious observer looks at a quantum system, something unique happens that forces the selection of a specific outcome from the range of quantum possibilities. This idea traces back to the early pioneers of quantum mechanics. Max Planck, who discovered quantum energy packets, believed consciousness was fundamental to physics. Werner Heisenberg argued that what we observe is not nature itself, but nature exposed to our method of questioning. Even John Wheeler, one of the most influential physicists of the 20th century, proposed that observation by conscious beings might be essential for giving the universe definite properties. He coined the term participatory universe to describe a cosmos where consciousness and physical reality are inseparably linked. But how could consciousness, apparently a product of brain activity, influence the behavior of fundamental particles? This question becomes even more puzzling when we consider the scale problem. Conscious brains are warm, wet, noisy environments where quantum effects should be destroyed by decoherence within microscopic fractions of a second. Yet somehow consciousness seems capable of triggering quantum wave function collapse in carefully isolated laboratory experiments. Some researchers propose that consciousness might operate through quantum mechanisms within the brain itself. Dr. Stuart Hameroff and Sir Roger Penrose developed a theory called orchestrated objective reduction, which suggests that consciousness emerges from quantum computations in cellular structures called microtubules. According to their model, consciousness involves quantum superpositions within neurons that collapse in synchronized events across the brain. These orchestrated quantum state reductions could provide a mechanism for conscious influence over quantum systems beyond the brain. Critics point out that the brain seems too warm and chaotic to maintain the delicate quantum coherences that this theory requires. But recent discoveries of quantum effects in biological systems have made such proposals more plausible. Quantum coherence has been observed in photosynthesis, where plants use quantum superposition to find the most efficient energy transfer pathways. Birds appear to use quantum entanglement in their magnetic navigation systems. Even the sense of smell might involve quantum tunneling effects that allow molecules to be identified by their vibrational frequencies. If biology can harness quantum mechanics for these functions, perhaps consciousness represents an even more sophisticated form of quantum information processing. But the consciousness interpretation faces deeper philosophical challenges that go to the heart of what we mean by observation and measurement. Does consciousness require a conscious observer, or can any information-gathering process trigger wave function collapse? This question has led to some of the most bizarre experiments in the history of science. In 1998, researchers at the Weizmann Institute in Israel designed an experiment to test whether consciousness itself was necessary for the observer effect. They set up a double-slit experiment but replaced human observers with electronic detectors that could record which slit each electron passed through. The results were identical to experiments with conscious observers. The mere presence of the detector, whether or not any human ever looked at the data, was enough to eliminate the interference pattern. The electrons behaved like particles instead of waves, even when no conscious mind was aware of the measurement. This seemed to suggest that consciousness wasn't special after all. Any device capable of gathering information about a quantum system could trigger wave function collapse. The observer effect appeared to be about information, not consciousness. But then the researchers pushed the experiment further. They introduced a quantum eraser that could delete the path information after it had been recorded by the detector. If they erased the which path data before anyone could access it, the interference pattern returned. Even more strangely, they could choose whether to erase the information or preserve it after the electrons had already hit the detection screen. The decision to erase or keep the path data, made after the measurement was complete, retroactively determined whether the electrons had behaved as waves or particles during their journey. This suggested something profound about the relationship between information and reality. It wasn't enough for information to exist. Something had to be capable of accessing and interpreting that information for it to have physical consequences. Dr. Yakir Aharonov, one of the experiment's designers, proposed that quantum mechanics might be fundamentally about the flow of information between past and future. Present measurements don't just reveal what happened in the past. They participate in defining what the past was. This leads to what physicists call retrocausality, the idea that future events can influence past events through quantum mechanical processes. If consciousness plays a role in collapsing wave functions, then conscious decisions in the future might literally reshape what happened in the past. The implications stretch far beyond laboratory experiments. If consciousness can influence quantum systems retroactively, then every conscious decision you make might be reaching backward through time to alter the chain of events that led to that decision. Consider what this means for free will and determinism. Classical physics suggested that the present state of the universe completely determines its future evolution. Every event follows inevitably from the laws of physics acting on previous conditions. Human consciousness appeared to be just along for the ride, experiencing the illusion of choice in a completely determined cosmos. But quantum mechanics introduces fundamental uncertainty into this picture. The future is not completely determined by the past. Instead, the present moment represents a selection from multiple possible futures, each with its own probability of occurring. If consciousness participates in this selection process, then free will might be more than an illusion. Every conscious decision could represent a genuine choice point where the universe's evolution branches into different possible futures. Dr. Henry Stapp, a quantum physicist at Berkeley, has argued that consciousness must play an active role in quantum measurement because purely physical processes cannot account for the definite outcomes we observe. According to his interpretation, consciousness doesn't just observe reality, it participates in creating reality through an ongoing series of choices. But this raises uncomfortable questions about the nature of reality itself. If conscious observation is required to collapse quantum superpositions into definite outcomes, what happens to parts of the universe that no conscious being observes? The cosmic consciousness problem becomes even more puzzling when we consider the early universe. For the first few 100,000 years after the Big Bang, the cosmos was too hot for atoms to form, let alone stars, planets, or conscious observers. Yet quantum mechanical processes were occurring throughout space during this period. Did the early universe exist in a state of permanent quantum superposition until the first conscious observers evolved billions of years later? Or does consciousness itself have a deeper history than we realize? Some physicists propose that consciousness might be a fundamental feature of the universe, present at every level of organization from elementary particles to complex brains. This view, called Panpsychism, suggests that even electrons and photons possess rudimentary forms of consciousness that allow them to collapse their own wave functions. Dr. David Chalmers, a philosopher at New York University, has argued that consciousness might be as fundamental as mass, charge, or spin. Just as we don't try to explain why particles have mass in terms of other properties, we might not need to explain consciousness in terms of purely physical processes. If consciousness is fundamental, then the observer effect becomes less mysterious. Every quantum interaction involves conscious entities making choices about which outcomes to manifest from the range of quantum possibilities. But this raises new questions about the relationship between individual consciousness and collective reality. If multiple conscious observers look at the same quantum system, whose consciousness determines the outcome? Experiments with multiple observers have produced puzzling results. When several people observe the same quantum measurement, they always agree on what they see. The wave function appears to collapse into the same outcome for everyone, rather than different outcomes for different observers. This suggests that consciousness might operate collectively rather than individually when, of a larger unified consciousness that encompasses all what we think of as individual consciousness is actually part, it comes to quantum measurement, perhaps observers. Dr. Amit Goswami, a quantum physicist turned consciousness researcher, has proposed that consciousness is the fundamental reality from which material existence emerges. In his interpretation, the universe consists of consciousness observing itself through countless individual perspectives. Each conscious observer represents a localized aspect of this universal consciousness, participating in the ongoing creation of material reality through quantum mechanical processes. What we experience as the physical world is actually the result of consciousness observing its own quantum possibilities and selecting specific outcomes. This might explain why the laws of physics appear so precisely fine-tuned for the existence of conscious observers. If consciousness is primary and matter secondary, then the physical universe would naturally be organized in ways that support the emergence and evolution of consciousness. But even if consciousness plays a fundamental role in quantum mechanics, we still face the question of how it actually works. What is the mechanism by which conscious observation triggers wave function collapse? One possibility involves quantum information processing in the brain. Dr. Stuart Hameroff's research on microtubules suggests that neurons might function as quantum computers, processing information through quantum superposition and entanglement. If consciousness involves quantum computations within the brain, then conscious observation might trigger wave function collapse through quantum mechanical interactions between the brain and external quantum systems. The act of becoming conscious of a measurement result could create quantum entanglement between the observer's brain and the measured system. Recent experiments have demonstrated that quantum entanglement can persist over surprisingly large distances and timescales. Researchers have created entangled photons that remain connected across hundreds of miles, with measurements on one photon instantly affecting its partner regardless of the distance between them. If consciousness can become quantum entangled with external systems, this might provide the mechanism for conscious influence over quantum measurements. The brain's quantum state could become correlated with the quantum state of measured systems, allowing conscious decisions to influence which outcomes are selected from quantum superpositions. But this raises questions about the boundaries of consciousness and its influence over physical reality. If consciousness can affect quantum systems through entanglement, how far does this influence extend? Dr. Dean Radin at the Institute of Noetic Sciences has conducted experiments suggesting that conscious intention might influence quantum random number generators from distances of thousands of miles. His results indicate that focused mental attention can create small but statistically significant biases in quantum mechanical processes. While these experiments remain controversial, they point toward possibilities that mainstream science has barely begun to explore. If consciousness can influence quantum systems through non-local connections, then the observer effect might be just the tip of an iceberg involving much deeper relationships between mind and matter. The implications would be revolutionary. Every conscious thought and decision might participate in shaping physical reality through quantum mechanical processes that connect individual minds to the fundamental structure of the universe. This brings us to one of the most startling possibilities suggested by quantum consciousness research. If consciousness can influence quantum systems, And if quantum mechanics governs all physical processes, then consciousness might be capable of directly affecting any aspect of material reality. The placebo effect, where belief alone can produce measurable physiological changes, might represent consciousness influencing quantum processes within biological systems. Prayer and meditation practices that appear to affect physical healing could involve consciousness directing quantum mechanical processes in ways that promote recovery. Even more remarkably, if consciousness operates through quantum mechanical principles, then individual minds might be capable of accessing information from across space and time through quantum entanglement effects. What we call intuition or psychic phenomena might represent consciousness tapping into quantum information networks that connect all things. Dr. Rupert Sheldrake's research on morphic resonance suggests that consciousness might access information fields that extend beyond individual brains. His experiments on telephone telepathy and the sense of being stared at indicate that consciousness might operate through mechanisms that conventional neuroscience doesn't recognize. If consciousness is fundamentally quantum mechanical, then the boundaries we draw between self and world, mind and matter, past and future, might be artificial constructs that don't reflect the true nature of reality. Instead of being isolated observers looking at an external world, we might be integral participants in an interconnected cosmic consciousness that experiences itself through countless individual perspectives. This possibility transforms the observer effect from a curious feature of quantum mechanics into evidence for something far more profound. The fact that conscious observation affects quantum systems might indicate that consciousness and physical reality are two aspects of a single underlying phenomenon. Rather than consciousness emerging from complex arrangements of matter, matter might emerge from the creative activity of consciousness observing its own infinite potential and selecting specific possibilities to manifest as physical experience. This perspective fundamentally reframes our understanding of evolution and the development of complexity in the universe. If consciousness is the driving force behind quantum wave function collapse, then the emergence of increasingly sophisticated conscious observers might represent the universe becoming more capable of observing itself with greater precision and awareness. Consider the implications for cosmic evolution. The universe began as a quantum foam of pure possibility, with no definite properties until conscious observation began selecting specific outcomes from infinite potential. As primitive forms of consciousness emerged, they started collapsing wave functions and creating the first stable particles and structures. Over billions of years, evolution produced increasingly complex conscious systems capable of more sophisticated observations. Each new level of consciousness expanded the universe's ability to observe itself, leading to the manifestation of ever more intricate and organized forms of matter and energy. Human consciousness might represent a critical threshold in this cosmic process. For the first time in Earth's history, conscious observers have developed the ability to deliberately design and conduct quantum experiments. We can consciously choose what to observe and how to observe it, potentially giving us unprecedented power to influence the fundamental structure of reality. Dr. John Wheeler recognized this revolutionary possibility when he proposed the it from bit hypothesis. According to Wheeler, all physical entities derive from information-based processes. What we call matter and energy might be manifestations of pure information being processed by cosmic consciousness. In this view, every quantum measurement represents consciousness asking the universe a yes or no question, and the universe responds by selecting one answer from all possible responses. Physical reality emerges from an ongoing dialogue between consciousness and quantum possibility, with each observation adding new information to the cosmic database of definite facts. But this raises profound questions about the relationship between individual consciousness and universal consciousness. If reality emerges from conscious observation, whose consciousness is doing the observing when no human is present? The answer might lie in recognizing that consciousness operates at multiple scales simultaneously. Just as quantum effects occur at the molecular level within our brains, while we experience unified conscious awareness, cosmic consciousness might operate through countless individual perspectives while maintaining overall coherence and consistency. Recent experiments have begun exploring whether quantum effects in biological systems could provide mechanisms for consciousness to influence physical processes beyond the brain. Dr. Anirban Bandyopadhyay's research on microtubule quantum vibrations suggests that every cell in the human body might be capable of quantum information processing. If consciousness operates through quantum mechanisms distributed throughout biological systems, then the observer effect might extend far beyond laboratory experiments. Every living organism could be continuously collapsing wave functions and participating in the ongoing creation of physical reality. This possibility gains support from studies of quantum coherence in photosynthesis, where plants demonstrate the ability to maintain quantum superpositions long enough to explore multiple energy transfer pathways simultaneously before selecting the most efficient route. These biological quantum computations suggest that life itself might be fundamentally quantum mechanical in nature. Dr. John Joe McFadden's research on quantum biology has revealed that many biological processes depend on quantum effects that classical physics cannot explain. DNA replication, enzyme catalysis, and even neural signal transmission involve quantum tunneling, coherence, and entanglement effects. If biological systems routinely harness quantum mechanics, then the boundary between living and non-living matter might be more fundamental than previously recognized. Life could represent the emergence of localized conscious observers capable of collapsing quantum wave functions and creating increasingly ordered structures from chaotic possibility that consciousness doesn't. This interpretation suggests just observe evolution. It drives evolution by continuously selecting beneficial outcomes from quantum superpositions of genetic possibilities. Natural selection might operate through conscious choice at the quantum level, with organisms unconsciously biasing quantum processes towards survival-enhancing outcomes. The implications extend to human consciousness and its potential role in directing our own evolution. If consciousness can influence quantum systems, then focused intention and visualization might be capable of affecting biological processes within our own bodies. Dr. Joe Dispenza's research on meditation and neuroplasticity suggests that consciousness can indeed reshape brain structure through focused mental practices. His studies show that meditation can increase grey matter density, strengthen neural connections, and even influence gene expression patterns. If consciousness operates through quantum mechanisms, these changes might result from the brain's quantum systems being directed towards specific outcomes through conscious intention. Rather than being passive observers of our own neural activity, we might be active participants in shaping our brain structure and function. The quantum consciousness hypothesis also offers new perspectives on memory and learning. Instead of memories being stored in specific neural locations, they might be encoded in quantum field patterns that extend throughout the brain and potentially beyond it. Dr. Carl Pribram's holographic brain theory proposes that memories are distributed across neural networks in ways that mirror how information is stored in optical holograms. Each part of the brain contains information about the whole, allowing memories to survive even significant brain damage. If memories are stored in quantum field patterns, then consciousness might be able to access information from across space and time through quantum entanglement effects. What we experience as memory recall might involve consciousness resonating with quantum information fields that contain records of past experiences. This could explain phenomena like déjà vu, where people experience strong feelings of familiarity with situations they've never encountered before. If consciousness can access quantum information networks, then we might occasionally tap into memories or experiences from other times and places. Dr. Rupert Sheldrake's morphic field theory suggests that consciousness might indeed access information from beyond individual brains through field effects that connect similar forms across space and time. His experiments on animal behavior indicate that learning in one location can somehow influence similar learning processes in distant locations. If consciousness operates through quantum field effects, then individual minds might be nodes in a vast information network that encompasses all conscious observers throughout space and time. Each conscious experience would contribute to this collective knowledge base while also having access to information from the entire network. This possibility transforms education and learning from individual processes to participation in cosmic consciousness evolution. Every insight gained by human consciousness would become available to the entire network, accelerating the development of knowledge and understanding across all connected minds. The implications for human potential are staggering. If consciousness can access quantum information networks, then the limitations we perceive might be self-imposed boundaries rather than fundamental constraints. Focused consciousness might be capable of accessing any information that exists within the cosmic network. This could explain extraordinary human abilities that conventional science struggles to understand. Mathematical prodigies who can perform complex calculations instantly, artistic geniuses who channel inspiration from unknown sources, and scientific innovators who make breakthrough discoveries through sudden insights might all be accessing information through quantum consciousness networks. Dr. Eben Alexander's research on near-death experiences suggests that consciousness might indeed be capable of accessing information beyond the physical brain. His studies of people who reported detailed awareness during cardiac arrest when brain activity was minimal or absent indicate that consciousness might operate through mechanisms that transcend neural activity. If consciousness is fundamentally quantum mechanical, then it might persist even when biological processes shut down. Near-death experiences could represent consciousness temporarily accessing the broader quantum information network without the filtering effects of normal brain activity. But the quantum consciousness hypothesis faces significant challenges from neuroscientists who argue that the brain is too warm and chaotic to maintain the delicate quantum coherences that such theories require. Random thermal motion should destroy quantum superpositions within tiny fractions of a second. However, recent discoveries in quantum biology have shown that biological systems can indeed maintain quantum coherence at body temperature through sophisticated molecular mechanisms that protect quantum states from environmental disruption. Nature appears to have evolved numerous strategies for harnessing quantum effects in warm, wet, noisy biological environments. Dr. Thorsten Ritz's research on avian magnetic navigation demonstrates that birds maintain quantum entanglement in specialized proteins within their eyes, allowing them to literally see magnetic fields as visual overlays on their normal vision. These quantum compass systems function perfectly at body temperature despite the challenging thermal environment. If evolution has produced quantum sensors that work in biological systems, then quantum information processing in the brain becomes much more plausible. The brain might employ similar protective mechanisms to maintain quantum coherences necessary for consciousness and observation effects. The question becomes not whether quantum effects can survive in biological systems, but how consciousness harnesses these effects to influence physical reality through observation and intention. The mechanism might involve quantum field interactions that extend beyond the boundaries of individual neurons or even individual brains. Dr. Penrose and Hameroff's orchestrated objective reduction theory proposes that consciousness emerges from quantum computations that occur simultaneously across networks of neurons. These quantum computations would culminate in orchestrated wave function collapse events that correspond to moments of conscious awareness. According to their model, each conscious moment represents billions of quantum superpositions collapsing in synchronized fashion across the brain. This orchestrated collapse would create the unified conscious experience while also potentially influencing external quantum systems through entanglement effects. Recent experiments by Dr. Anirban Bandyopadhyay have provided some support for quantum effects in microtubules, the cellular structures that Penrose and Hameroff identified as potential sites for quantum computation. His measurements reveal electromagnetic oscillations in microtubules that display characteristics consistent with quantum mechanical processes. If consciousness does emerge from quantum computations in the brain, then the observer effect becomes a natural consequence of conscious awareness. Each moment of consciousness would involve quantum measurements occurring within the brain, and these measurements could influence external quantum systems through the same mechanisms that create conscious experience. This suggests that consciousness and the observer effect are two aspects of the same underlying phenomenon. Consciousness represents the subjective experience of quantum wave function collapse, while the observer effect represents the objective influence that these collapse events have on external quantum systems. The boundary between observer and observed dissolves when we recognize that both involve the same fundamental process of quantum possibility being collapsed into definite outcomes through conscious interaction. What we call objective reality might be the collective result of countless conscious observers continuously collapsing quantum superpositions through their ongoing awareness. This interpretation offers a solution to the measurement problem that has puzzled quantum physicists for nearly a century. Instead of treating measurement as a mysterious process that occurs when quantum systems interact with classical measuring devices, we can understand measurement as conscious awareness interacting with quantum possibility. Every conscious observation represents a question posed to the universe, and the universe responds by selecting one answer from all possible responses. Physical reality emerges from this ongoing dialogue between consciousness and quantum potential, with each observation contributing to the growing database of definite facts that we experience as the material world. But this raises new questions about the relationship between individual consciousness and collective reality. If multiple conscious observers look at the same quantum system, how is consensus reality maintained? Why do all observers agree on what they see instead of each experiencing different outcomes? The answer might involve quantum entanglement between conscious observers. When multiple minds focus on the same quantum system, their consciousness might become entangled, forcing them to experience correlated outcomes. Consensus reality would emerge from the quantum mechanical requirement that entangled systems maintain consistent correlations. Dr. Dean Radin's experiments on collective consciousness effects suggest that groups of people focusing on the same intention can indeed influence quantum random number generators more effectively than individuals acting alone. These results indicate that consciousness might operate collectively when multiple observers coordinate their attention. If consciousness operates through quantum entanglement effects, then human civilization represents an emerging collective consciousness capable of influencing physical reality through coordinated observation and intention. Global meditation events, mass prayers, and shared cultural practices might literally reshape the quantum foundations of reality through collective consciousness effects. This possibility transforms our understanding of social and cultural evolution. Instead of being purely mimetic processes involving the transmission of ideas, cultural changes might involve consciousness actively reshaping reality through quantum mechanical processes that operate beyond individual brains. The development of scientific instruments and measurement technologies would represent consciousness extending its observational capabilities beyond biological limitations. Telescopes, microscopes, and particle detectors become tools that allow consciousness to observe quantum systems at scales and in domains that biological senses cannot access. Each new scientific discovery would represent consciousness expanding its influence over quantum reality by developing new ways to collapse wave functions and determine definite outcomes. The history of science becomes the history of consciousness learning to observe and influence increasingly subtle aspects of quantum possibility. This transformation of scientific discovery into conscious evolution explains why quantum mechanics emerged precisely when human consciousness reached sufficient sophistication to design controlled experiments. Before the 20th century, we lacked the technological capabilities to isolate individual quantum systems and observe their behavior directly. But as soon as we developed the instruments necessary to probe quantum reality, we discovered that consciousness plays a fundamental role in determining what we observe. This timing might not be coincidental. Perhaps consciousness and quantum mechanics were discovered together because they represent two aspects of the same underlying phenomenon. Consider what happens when you walk into a quantum physics laboratory today. Lasers create coherent photons that exist in perfect superposition until the moment of detection. Superconducting circuits maintain quantum states at temperatures colder than outer space. Magnetic fields isolate individual atoms from environmental interference. These technologies represent consciousness extending its reach into realms that natural selection never prepared our brains to access. We've created artificial sense organs capable of detecting individual particles and measuring quantum properties with extraordinary precision. But here's what's remarkable. The moment we point these instruments at quantum systems, the same observer effect occurs that happens with direct conscious observation. The instruments become extensions of consciousness, allowing human awareness to collapse wave functions at scales from individual photons to complex molecular systems. Dr. Wojciech Zurek's research on quantum decoherence reveals that the boundary between quantum and classical behavior depends critically on the type of measurement being performed. Systems remain quantum as long as no information about their state leaks into the environment. The instant information becomes available to potential observers, classical behavior emerges. This suggests that consciousness doesn't need direct contact with quantum systems to influence them. Any process that makes quantum information potentially observable by conscious minds can trigger wave function collapse. The mere possibility of conscious observation appears sufficient to transform quantum superposition into classical reality. Recent experiments have pushed this principle to its absolute limits. Researchers at Griffith University in Australia created quantum systems where the decision to observe could be delayed until after particles had completed their entire journey through the experimental apparatus. Even retroactive decisions to observe or not observe affected the quantum behavior that had supposedly already occurred. The implications stretch our understanding of causation itself. If future conscious decisions can influence past quantum events, then the linear progression from cause to effect that we take for granted in everyday experience might not reflect the true nature of reality. Instead, consciousness might participate in a cosmic feedback loop where present observations help determine past events, while past events help determine present observations. The universe becomes a self-consistent system where consciousness and physical reality co-create each other through quantum mechanical interactions that transcend ordinary space and time. Dr. Yakir Aharonov's two-state vector formalism provides a mathematical framework for understanding these retroactive effects. According to his interpretation, quantum systems exist in superposition between their initial preparation and final measurement, with the complete description requiring information from both the past and future. The present moment becomes a meeting point where past possibilities and future observations interact to determine what actually happened. Consciousness doesn't just observe this process, it participates in defining which possibilities from the past become actualized through present and future measurements. This retroactive aspect of consciousness challenges our most basic assumptions about personal identity and free will. If your conscious decisions can influence past events, then the chain of experiences that shaped your current consciousness might itself be influenced by decisions you haven't made yet. The person you become through future conscious choices might retroactively influence the experiences that shaped you into someone capable of making those choices. Personal development becomes a self-consistent loop where future consciousness helps create the past experiences that enable that future consciousness to emerge. Dr. Avshalom Elitzer's research on quantum mechanical time loops suggests that consciousness might indeed operate through such self-referential processes. His theoretical work indicates that quantum systems can maintain consistency even when causal loops occur, as long as the information flow remains self-consistent. Applied to consciousness, this means your future decisions could influence your past experiences, but only in ways that remain consistent with the person you actually became. The universe enforces logical consistency across time, but allows consciousness tremendous freedom in determining which consistent possibilities actually occur. This has profound implications for personal responsibility and the meaning of choice. Every conscious decision you make might be simultaneously determined by your past experiences, and determining those past experiences through retroactive quantum effects. Free will and determinism become complementary aspects of a deeper reality where consciousness participates in creating the very history that shapes it. But the quantum consciousness hypothesis extends beyond individual minds to encompass collective human consciousness and its role in shaping shared reality. If individual observers can influence quantum systems through conscious attention, then groups of observers focusing on the same phenomena might produce collective effects that exceed what any individual could achieve alone. Dr. Roger Nelson's Global Consciousness Project has been monitoring networks of random number generators around the world since 1998, looking for correlations that might indicate collective consciousness effects. Their data shows subtle but statistically significant deviations from randomness during major global events that capture widespread human attention. The September 11th attacks, the 2004 Indian Ocean tsunami, and the death of Princess Diana all produced measurable effects in quantum random number generators scattered across the planet. These correlations suggest that collective human consciousness might indeed influence physical processes through quantum mechanical mechanisms. The effect sizes are small, but they occur consistently across multiple independent measurement systems, making random chance an unlikely explanation. If confirmed, these results would indicate that human civilization represents an emerging collective consciousness capable of influencing physical reality through coordinated attention and emotion. Consider what this means for historical events and social movements. Mass gatherings, religious ceremonies, and political demonstrations might literally reshape reality through the collective consciousness effects of thousands or millions of minds focusing on shared intentions and expectations. The power of belief systems, cultural myths, and social movements might stem not just from their psychological effects on human behavior, but from their ability to focus collective consciousness on specific outcomes, thereby biasing quantum processes toward the manifestation of those outcomes. Dr. Rupert Sheldrake's morphic resonance theory proposes that collective consciousness operates through field effects that strengthen with repetition. Each time a group of conscious observers focuses on similar patterns or intentions, they make it easier for future groups to access and amplify those same patterns. Cultural traditions, scientific paradigms, and artistic movements might gain momentum through morphic resonance effects, where collective consciousness creates information fields that influence future conscious observers. Innovation and discovery become processes where individual consciousness taps into collective fields of accumulated knowledge and intention. This could explain why scientific breakthroughs and artistic innovations often occur simultaneously in different locations, with multiple researchers or artists developing similar ideas independently. Rather than mere coincidence, these synchronicities might reflect consciousness accessing collective information fields that contain emerging possibilities. The implications transform our understanding of human potential and cultural evolution. Instead of being limited to the knowledge and capabilities contained within individual brains, consciousness might have access to the accumulated wisdom and experience of all humanity through quantum information networks. Education becomes a process of learning to access these collective fields rather than simply memorizing information. Creativity involves tuning consciousness to emerging possibilities within the collective field, rather than generating entirely novel ideas from individual imagination alone. But this raises questions about the boundaries and limitations of collective consciousness effects. If human consciousness can influence quantum processes through collective attention, how far does this influence extend? Are there quantum systems too large or too isolated for consciousness to affect? Recent experiments suggest that the scale limitations might be less restrictive than previously thought. Researchers have demonstrated quantum effects in systems containing billions of particles and have created quantum entanglement between objects visible to the naked eye. Dr. Marcus Aspelmeyer's team at the University of Vienna has achieved quantum superposition in mechanical oscillators large enough to see without magnification. These macro-scale quantum effects suggest that consciousness might be capable of influencing physical systems at scales approaching everyday experience. If consciousness can affect quantum systems at macro scales, then the boundary between mind and matter becomes increasingly blurred. Physical objects might be more responsive to conscious intention than classical physics suggests, especially when multiple observers coordinate their attention on the same targets. This possibility gains support from studies of psychokinesis, where individuals attempt to influence physical systems through mental intention alone. While the effects are typically small and require sophisticated statistical analysis to detect, numerous experiments have found evidence for consciousness affecting random number generators, radioactive decay rates, and even mechanical systems. Dr. Robert Jahn's research at Princeton University documented thousands of experiments where human intention appeared to influence the output of electronic random event generators. The effect sizes were small but consistent across different operators, different machines, and different experimental conditions. Meta-analyses of psychokinesis experiments reveal overall effect sizes that are statistically significant despite being individually subtle. This suggests that consciousness might indeed be capable of directly influencing physical systems through quantum mechanical processes that operate below the threshold of ordinary perception. If consciousness can influence quantum systems directly, then the technologies we develop to amplify and focus conscious intention might represent the next stage in human evolution. Biofeedback devices, meditation technologies, and brain-computer interfaces could become tools for enhancing consciousness's ability to interact with quantum reality. The development of quantum computers might provide particularly powerful platforms for consciousness-machine interaction. These systems maintain quantum superposition states that are naturally sensitive to environmental influences, potentially making them ideal interfaces for conscious control of quantum processes. Dr. Stuart Hameroff has proposed that quantum computers might eventually be designed to interface directly with consciousness through quantum effects in microtubules within neurons. Such systems could allow conscious intention to directly program quantum computations, creating unprecedented opportunities for mind-machine integration. But the ultimate implications of quantum consciousness extend far beyond technological applications. If consciousness is fundamental to quantum mechanics, and quantum mechanics governs all physical processes, then consciousness might be the primary creative force in the universe. Every conscious moment represents an act of creation where infinite possibilities collapse into definite outcomes through the mysterious process of observation. What we call physical reality might be the ongoing result of consciousness observing its own infinite potential and selecting specific possibilities to experience as material existence. This transforms our understanding of purpose and meaning in the universe. Instead of consciousness being an accidental byproduct of complex matter, matter might be an intentional creation of consciousness exploring its own capabilities through the experience of physical existence. The evolution of complexity in the universe, from simple particles to complex molecules to living systems to conscious observers, might represent consciousness gradually developing more sophisticated ways to observe and influence its own quantum nature. Each new level of complexity provides consciousness with enhanced capabilities for collapsing wave functions and creating increasingly organized structures from quantum possibility. The emergence of human consciousness represents a critical threshold where conscious observers develop the ability to deliberately design quantum experiments and study their own role in creating reality. We stand at a unique moment in cosmic evolution where consciousness has become sufficiently sophisticated to recognize its own fundamental role in shaping existence. This recognition carries enormous responsibility because it suggests that conscious choices about how to observe and interact with quantum systems might literally determine the future evolution of reality itself. The quantum observer effect reveals that consciousness is not separate from the universe it observes, but rather the primary mechanism through which the universe creates itself moment by moment through the ongoing collapse of infinite possibility into experienced actuality. What happens when we push this understanding to its absolute limits? Recent experiments have ventured into territory that challenges not just our scientific assumptions, but our basic conception of what it means to exist as conscious beings in a quantum universe. In laboratories around the world, researchers are discovering that the quantum observer effect extends far beyond simple particle interactions. Dr. Lucian Hardy at the Perimeter Institute designed an experiment that seems to violate the very foundations of logical reasoning. He created a quantum system where the presence or absence of an observation appears to generate paradoxes that should be impossible within any consistent reality. The experiment involves photons in superposition states that can take multiple paths simultaneously through an optical setup. But here's where it gets mind-bending. Hardy discovered configurations where the logic of classical reasoning breaks down completely. If you assume the photons behave classically, you reach contradictory conclusions about whether they were detected or not detected. The only way to resolve these paradoxes is to accept that reality remains fundamentally uncertain until conscious observation forces it to choose consistent outcomes. The universe appears to maintain logical coherence not through predetermined properties, but through dynamic adjustments that occur at the moment of measurement. This suggests something profound about the relationship between consciousness and logical consistency. Perhaps consciousness doesn't just observe reality, it actively participates in maintaining the logical structure that makes reality comprehensible in the first place. Dr. Czeslaw Bruckner at the University of Vienna has pushed these ideas even further with experiments on quantum superposition of causal order. His team created systems where the sequence of events itself exists in quantum superposition until observation determines which event happened first. Imagine flipping two coins where the order of the flips remains undetermined until someone observes the results. The first coin could be flipped before, after, or simultaneously with the second coin, with all possibilities existing in superposition until measurement collapses the causal structure into a definite sequence. These experiments demonstrate that consciousness might not just determine what happens, but when things happen and in what order. The temporal structure of reality itself could be subject to quantum uncertainty that gets resolved through conscious observation. The implications stretch our understanding of personal identity across time. If the sequence of your experiences can exist in quantum superposition until observation determines their order, then your sense of continuous identity through time might involve consciousness actively constructing a consistent narrative from quantum possibilities. Memory formation becomes even more mysterious in this context. When you remember a past experience, you might not just be recalling something that definitely happened. You might be participating in the retroactive determination of what actually occurred through the quantum mechanical process of remembering. Dr. Matthew Leifer at Chapman University has developed mathematical frameworks for understanding these temporal quantum effects. His work suggests that consciousness operates through what he calls quantum causal models, where cause and effect relationships remain probabilistic until observation collapses them into definite causal structures. This means every conscious moment involves making choices not just about what to experience, but about how to organize those experiences into coherent causal sequences. Your consciousness actively constructs the temporal flow of your existence through quantum mechanical processes that operate beyond ordinary awareness. But the most startling developments come from experiments that probe whether consciousness can influence quantum systems through pure intention without any physical interaction whatsoever. These investigations venture into territory that mainstream science has barely begun to acknowledge. Dr. Helmut Schmidt's pioneering work in the 1970s used radioactive decay as a quantum random number source, asking human subjects to mentally influence the timing of atomic decay events. Radioactive decay represents one of the most fundamentally random processes in physics, with quantum mechanics providing only statistical predictions about when individual atoms will decay. Yet Schmidt's experiments consistently showed small but statistically significant correlations between human intention and decay timing. Subjects who focused on trying to increase or decrease decay rates achieved results that deviated from pure randomness in the intended direction. These findings were so controversial that they were largely ignored by mainstream physics, but recent replications using more sophisticated equipment and stronger statistical controls have confirmed that consciousness can indeed influence quantum random processes through mechanisms that remain completely mysterious to conventional science. Dr. Dean Radin has extended these investigations using modern quantum random number generators based on photon detection. His experiments involve subjects attempting to influence the output of quantum devices through focused mental intention, with no possibility of sensory feedback or electromagnetic interference. The results consistently show effect sizes that are small but highly significant across thousands of experimental sessions. Meta-analyses reveal that the probability of these results occurring by chance is less than 1 in a trillion, making random coincidence an untenable explanation. Even more remarkably, the effects appear to be enhanced when multiple subjects coordinate their intentions, suggesting that collective consciousness can produce stronger influences on quantum systems than individual consciousness acting alone. These discoveries point toward possibilities that would revolutionize our understanding of human potential. If consciousness can directly influence quantum processes through intention alone, then the limitations we perceive in physical reality might be self-imposed constraints rather than fundamental laws of nature. Dr. William Tiller at Stanford University has conducted experiments suggesting that human intention can alter the properties of materials at the quantum level. His research involves subjects focusing mental intention on electronic devices with the goal of changing their functional characteristics. In controlled laboratory conditions, devices that received focused intention showed measurable changes in their electrical properties that persisted for months after the intention sessions ended. The affected devices were then used to influence chemical reactions, pH changes in water, and even the growth rates of biological organisms. These results suggest that consciousness might be capable of programming quantum information into physical systems, creating lasting changes that continue to influence material properties long after the original intention was applied. The mechanism remains completely unknown to conventional physics. There's no recognized force or field that could account for consciousness directly affecting quantum systems at a distance. Yet the experimental evidence continues to accumulate across multiple laboratories and research groups worldwide. Dr. Garrett Model at the University of Colorado has investigated whether consciousness can influence quantum tunneling rates in electronic devices. Quantum tunneling allows particles to pass through energy barriers that classical physics says should be impenetrable, making it a purely quantum mechanical phenomenon. His experiments involve subjects attempting to mentally influence the current flow through tunnel junctions, where electrons must tunnel through barriers to complete the circuit. The results show statistically significant correlations between human intention and tunneling rates, suggesting that consciousness can indeed affect fundamental quantum processes. These findings challenge the basic assumption that consciousness and physical reality operate through separate domains that can only interact through known sensory and motor pathways. Instead, they suggest direct quantum mechanical connections between mind and matter that bypass conventional biological mechanisms entirely. But perhaps the most profound implications emerge when we consider what these effects mean for our understanding of individual versus collective consciousness. If multiple people can coordinate their intentions to produce stronger effects on quantum systems, then human consciousness might naturally evolve toward greater collective integration. Dr. Roger Nelson's Global Consciousness Project has documented correlations between worldwide attention events and quantum random number generators that exceed what any classical theory can explain. Major news events, disasters, celebrations, and other phenomena that capture global attention consistently produce deviations from randomness in quantum devices scattered across the planet. The effect sizes are small, but remarkably consistent, appearing in data from dozens of locations simultaneously whenever human consciousness becomes collectively focused on shared events or concerns. This suggests that human civilization is developing into a genuinely collective consciousness capable of influencing physical reality through coordinated attention. The implications extend far beyond laboratory experiments. If collective consciousness can influence quantum processes, then mass movements, cultural shifts, and social transformations might involve consciousness literally reshaping the physical foundations of reality through quantum mechanical effects. Political elections, economic markets, and social movements could involve quantum consciousness effects, where collective human intention influences the probability of different outcomes. The power of belief systems and cultural narratives might stem from their ability to focus collective consciousness on specific possibilities, thereby biasing quantum processes toward the manifestation of expected outcomes. Dr. Rupert Sheldrake's morphic field theory proposes that collective consciousness creates information fields that influence the behavior of similar systems across space and time. Each time a group successfully achieves a particular outcome, they make it easier for future groups to achieve similar results through resonance effects in consciousness fields. This could explain why social changes often appear to occur simultaneously in different locations without direct communication between the groups involved. The morphic field effects of collective consciousness might coordinate social evolution across entire civilizations through quantum mechanical processes that operate beyond ordinary space and time constraints. Consider what this means for human cultural evolution. Instead of ideas spreading purely through communication and imitation, consciousness might actively reshape reality to make certain ideas and innovations more likely to emerge independently in multiple locations. Scientific discoveries, artistic movements, and social reforms could propagate through morphic resonance effects that influence the quantum foundations of creativity and innovation. The development of the internet and global communication technologies might represent consciousness creating physical infrastructures that mirror the quantum information networks through which collective consciousness naturally operates. Digital networks could be external manifestations of internal quantum connectivity that consciousness uses to coordinate collective effects across the planet. But this raises profound questions about the future evolution of human consciousness and its relationship to technology. If consciousness can influence quantum systems directly, then the artificial intelligence systems we're developing might become platforms for consciousness to extend its influence into digital realms. Quantum computers, with their delicate superposition states and sensitivity to environmental influences, could provide ideal interfaces for consciousness to interact with digital information processing. Instead of consciousness being replaced by artificial intelligence, we might see the emergence of hybrid consciousness machine systems that combine human awareness with quantum computational capabilities. Dr. Stuart Hameroff's research on quantum effects in biological systems suggests that consciousness already operates through quantum computational processes within the brain. Artificial quantum computers might simply provide consciousness with more powerful platforms for the same types of information processing that already occur naturally in biological systems. The integration of consciousness with quantum computing could produce capabilities that neither human consciousness nor artificial intelligence could achieve independently. Quantum-enhanced consciousness might develop the ability to process information and influence physical systems in ways that transform our understanding of what it means to be conscious beings in a quantum universe. But these possibilities also raise ethical concerns about the responsible development and application of consciousness-based technologies. If consciousness can directly influence quantum systems, then technologies that amplify or focus conscious intention could become incredibly powerful tools for shaping physical reality. The same capabilities that could be used for healing, environmental restoration, and positive social transformation could potentially be misused for manipulation, control, or destruction. Understanding the quantum observer effect becomes not just a scientific endeavor, but a moral imperative that determines how consciousness evolves in relationship to the reality it helps create. Dr. Amit Goswami argues that consciousness research requires a fundamental shift from materialist to consciousness-based science that recognizes awareness as the primary reality from which physical phenomena emerge. This perspective demands new ethical frameworks that account for consciousness as an active creative force rather than a passive observer. If consciousness participates in creating reality through quantum mechanical processes, then every conscious choice carries responsibility for the type of reality that emerges from quantum possibility. The observer effect becomes not just a curious feature of physics experiments, but evidence for consciousness as the fundamental creative principle in the universe. This transforms meditation, prayer, intention, and other consciousness practices from purely personal activities into participation in the ongoing creation of collective reality. Every moment of focused awareness becomes an opportunity to influence the quantum foundations of existence in ways that can benefit or harm the entire interconnected web of consciousness. Recent experiments have begun exploring whether consciousness can influence quantum systems in ways that produce practical benefits for human health and well-being. Dr. Rollin McCraty at the Institute of Heart Math has investigated whether focused intention activity and cellular metabolism. These effects occur conformation enzyme distances too great can affect physiological processes through quantum mechanical mechanisms. His research reveals that coherent emotional states characterized be explained by known biochemical signaling pathways. The results, the neural, or suggest that consciousness might influence biological systems through quantum field effects that operate faster activity, correlate with measurable changes in DNA by synchronized heart rhythms and brain too rapidly and at hormonal communication. Focused intention could directly affect the pure awareness. Chopra's collaboration, Dr. Deep with quantum physicists, has explored meditation practices correlate with changes in gene mechanisms for consciousness to influence physical health through quantum processes that govern cellular function, providing activity that promote health and longevity. IFD, whether meditation and consciousness practices can influence genetic tools for optimizing biological consciousness, can influence genetic expression through quantum mechanical processes. Their preliminary findings suggest that sustain, then practices that enhance conscious expression through quantum effects function and extending healthy lifespan. The place awareness might represent powerful rather than chemical EBO effect, spontaneous remissions, and other mysterious biological systems. These investigations works through quantum mechanical principles lead to therapeutic approaches that harness consciousness evolution itself. If consciousness can influence healing phenomena, might involve consciousness directing quantum processes within interventions. Understanding the observer effect that enhance conscious awareness might literally becomes a recognized medical modality that reality through quantum mechanical effects and intention. Then practices point toward a future where consciousness-based healing quantum systems through observation expand consciousness's ability to shape. Implications may involve as a direct healing force. But the most transformation and influence claims might reflect genuine enhancement. Meditation traditions have extraordinary capabilities, including expanded awareness, enhanced intuition, long claimed that sustained practice developed sun brewers significantly from normal W training. Dr. Ju over biological processes that beyond conscious control. These of consciousness's practitioners show unusual patterns of brain activity that differ. Research on meditation reveals that experienced normally operated meditators demonstrate enhanced connectivity between brain neuroscience aching consciousness. Advanced quantum mechanical capabilities through systematic regions, increased coherence in neural oscillations, and altered relationships extend beyond individual development. Consciousness operates through quantum mechanisms in the brain. Then meditation might coherent supercontemple, increasing to collective consciousness quantum systems between conscious awareness and automatic mental processes. If consciousness's ability to maintain quantum consciousness capabilities, the implications enhancementative practices can enhance these quantum processes, represent training techniques, can produce position states, and influence external methods for developing of people practicing consciousness evolution. If groups communities stronger effects on quantum systems than individuals, then to consciousness development dedicate might become centers of collective reality creation. Collective consciousness capabilities that These communities could become prot effect suggests that consciousness and can influence physical reality through quantum mechanical processes. Understanding this relationship becomes crucial for navigizations that operate through different O-types for consciousness-based civil principles than purely might serve not just as locations for personal growth, but as laboratories for developing monasteries, meditation centers, and spiritual communities, aiding the future evolution of human consciousness. And its role conscious moment represents a bring to these moments. Reality are not separate domains, but aspects of a single phenomenon. Materialistic societies shapes existence through quantum mechanical interactions. The observer actuality through the mysterious process of observation generations will inherit the quality in creating where awareness continuously choice point, where infinite possibilities collapse into experience the reality that future of consciousness we process. The observer beings to develop wisdom of reality that emerges from quantum uncertainty. This places enormous responsibility on conscious into existence through the ongoing collapse of quantum in their relationship to the quantum creative might literally determine the quality on whether along for the ride in deepen, compassion, and clarityed reality. The future a predetermined universe but actively participates in determining to use what kinesis of human civilization may affect reveals that consciousness is not just possibility into experience we learned of universe comes creative power, or whether we remain this quantum wisely, unconsigar step in the consciosity, but the essential role in shaping the reality we face choices, as we stand at the threshold of this recognition inhabit. Understanding, remain trapped in outdated whirl observer effect becomes not just a scientific curious evolution of awareness itself, mind from matter observer that will determine whether consciousness evolves toward greater harmony, views that separate with the quantum nature, or whether we of reality from observed consciousness and integration from the cosmos it continuously creates through the act of aware observation. The quantum universe is not a machine running according to predetermined programs. It is a living, responsive, creative medium that transforms infinite possibility into experienced reality through conscious participation in the fundamental process of existence itself. The implications become even more staggering when we examine consciousness at the moment of death itself. Dr. Pim van Lommel's research on near-death experiences has documented cases where patients reported detailed awareness during cardiac arrest, when brain activity was undetectable by medical instruments. These individuals described observing their own resuscitation from outside their bodies, recounting conversations and events that occurred while they were clinically dead. If consciousness operates through quantum mechanisms that extend beyond brain tissue, then death might not represent the end of awareness, but rather a transition to different modes of quantum information processing. The observer effect could persist even after biological processes cease, suggesting that consciousness might continue influencing quantum systems through non-local connections that transcend physical death. Dr. Bruce Grayson's studies at the University of Virginia have revealed that many near-death experiencers return with enhanced psychic abilities and altered relationships to physical reality. They report increased sensitivity to electromagnetic fields, precognitive dreams, and spontaneous healing abilities that suggest their consciousness has developed stronger connections to quantum information networks. These enhanced capabilities might result from consciousness temporarily accessing broader quantum fields during the death experience, returning with expanded capacity to influence physical systems through quantum mechanical processes. Death becomes not an ending, but a quantum phase transition that can fundamentally alter consciousness's relationship to material reality. But the quantum consciousness hypothesis raises profound questions about the continuity of individual identity across these transitions. If consciousness operates through quantum field effects that extend beyond individual brains, then personal identity might be more fluid and interconnected than we typically assume. Dr. Ian Stevenson's research on reincarnation cases documented thousands of children who reported detailed memories of previous lives, often including verifiable information they could not have acquired through normal means. His successor, Dr. Jim Tucker, has continued this work using modern investigative techniques that rule out fraud, coincidence, or information leakage through conventional channels. If consciousness can access quantum information networks that preserve experiences across time, then reincarnation might involve consciousness reconnecting with quantum field patterns that contain memories and personality traits from previous incarnations. Individual identity becomes a temporary configuration within larger consciousness networks rather than an isolated phenomenon confined to single lifetimes. This perspective transforms our understanding of personal development and spiritual growth. Instead of consciousness emerging from nothing at birth and disappearing at death, individual awareness might represent localized expressions of eternal consciousness fields that persist across multiple incarnations. Dr. Michael Newton's research on past life regression revealed consistent reports of consciousness existing in non-physical realms between incarnations, where individual awareness maintains continuity while also connecting with larger collective consciousness groups. These accounts suggest that physical incarnation might be just one mode of consciousness operation within a broader quantum reality. The implications extend to our understanding of human relationships and social connections. If consciousness operates through quantum entanglement effects, then the bonds we form with other people might involve genuine quantum mechanical connections that persist beyond physical separation or death. Dr. Rupert Sheldrake's experiments on telephone telepathy demonstrate that people can sense when distant friends or family members are about to call them, suggesting quantum information transfer between emotionally connected consciousness. These connections might represent quantum entanglement between individual consciousness fields that allows instantaneous information sharing across any distance. Parents often report sensing when their children are in danger, even when separated by thousands of miles. Identical twins frequently experience synchronous thoughts, emotions, and even physical sensations despite being in different locations. These phenomena might reflect consciousness operating through quantum networks that connect related individuals through non-local information channels. If consciousness creates quantum entanglement through emotional bonds and shared experiences, then human relationships involve literal quantum mechanical connections that allow consciousness to share information and influence across space and time. Love, empathy, and compassion become quantum phenomena that create measurable physical effects through consciousness field interactions. Recent experiments by Dr. Jacobo Grinberg-Zilberbaum demonstrated that when two people meditate together and develop rapport, their brain activity becomes synchronized even when they're placed in separate electromagnetically shielded rooms. When one person receives a light stimulus, both brains show identical neural responses, suggesting genuine quantum correlation between separate consciousness. These findings indicate that consciousness can create quantum entanglement between different individuals, allowing them to share experiences directly through quantum mechanical processes that bypass normal sensory channels. Collective meditation practices might literally create quantum networks that connect individual consciousness into larger collective awareness systems. Dr. Lynn McTaggart's research on group intention experiments has documented cases where coordinated consciousness appears to influence distant targets through quantum field effects. Groups focusing collective intention on specific goals have produced measurable changes in plant growth, bacterial cultures, and even crime rates in targeted geographical areas. The most striking results occur when groups achieve coherent emotional states characterized by synchronized heart rhythms and brainwave patterns. This physiological coherence appears to enhance the group's ability to influence quantum systems through collective consciousness effects that exceed what individual participants could achieve alone. If collective consciousness can influence physical reality through quantum mechanical processes, then human civilization represents an emerging planetary consciousness capable of directing the evolution of Earth's biosphere through coordinated intention and awareness. Environmental healing, species conservation, and climate stabilization might be achievable through consciousness-based interventions that operate at quantum scales. But this power carries enormous responsibility. If consciousness shapes reality through quantum observation effects, then the quality of human consciousness directly determines the quality of the reality we collectively create. Negative emotions, destructive thoughts, and unconscious behaviors might literally poison the quantum field through consciousness effects that manifest as environmental destruction, social conflict, and biological dysfunction. Dr. Masaru Emoto's controversial research on water crystal formation suggested that human consciousness can affect the molecular structure of water through quantum information transfer. While his methodology has been criticized, independent reports have confirmed that focused intention can indeed influence the crystallization patterns of water samples. Since human bodies are primarily composed of water, and water molecules maintain quantum coherence longer than previously thought possible in biological systems, consciousness might continuously influence our own cellular structure through quantum effects on the water within our tissues. Every thought and emotion could literally reshape our physical bodies at the molecular level through consciousness-directed quantum processes. This understanding transforms health and healing from purely biochemical processes into consciousness-matter interactions that operate through quantum mechanical principles. Disease might represent consciousness patterns that create destructive quantum field effects within biological systems, while healing involves consciousness establishing quantum coherence that promotes optimal cellular function. Dr. Deepak Chopra's research on mind-body medicine has documented cases where meditation practices produce rapid changes in gene expression, immune function, and cellular repair mechanisms. These effects occur too quickly to be explained through conventional biochemical signaling, suggesting that consciousness influences biological systems through quantum field interactions that operate faster than molecular processes. If consciousness can directly influence genetic expression through quantum effects, then practices that enhance conscious awareness might represent powerful tools for optimizing health and extending lifespan. Meditation, prayer, visualization, and other consciousness practices become medical interventions that harness quantum mechanics for therapeutic purposes. But the deepest implications emerge when we consider consciousness evolution itself. If human awareness continues developing enhanced quantum capabilities, we might be approaching a phase transition where consciousness transcends its current biological limitations and begins operating through purely quantum mechanical processes. Advanced meditators report experiences of expanded awareness that seem to transcend individual identity entirely. They describe consciousness merging with universal awareness, where the boundaries between self and cosmos dissolve completely. These states might represent consciousness temporarily accessing its fundamental quantum nature beyond the filtering effects of brain-based processing. Dr. Ibn Alexander's near-death experience research suggests that consciousness might naturally evolve toward these expanded states through biological death and rebirth cycles that gradually enhance quantum processing capabilities. Each incarnation could represent consciousness developing greater capacity to maintain quantum coherence and influence physical systems through pure awareness. The ultimate implications point toward consciousness eventually transcending physical embodiment entirely, operating through pure quantum field effects that maintain information processing and creative capabilities without requiring material substrates. Individual awareness might merge into collective consciousness networks that span cosmic scales while maintaining the capacity for infinite creative expression. This cosmic consciousness would represent the universe becoming fully aware of itself through the evolution of quantum information processing systems capable of observing and influencing reality at every scale simultaneously. The observer effect becomes the mechanism through which the cosmos achieves complete self-knowledge through conscious participation in its own creative unfolding. Recent discoveries in quantum biology suggest that this evolution might already be underway. Quantum effects in photosynthesis, neural microtubules, and genetic replication indicate that biological systems are developing enhanced quantum processing capabilities that could serve as stepping stones toward purely consciousness-based existence. Dr. Stuart Hameroff's latest research reveals that quantum coherence in biological systems can persist for much longer periods than classical physics predicts, suggesting that evolution is selecting for organisms with enhanced quantum information processing capabilities. Consciousness might be driving its own biological evolution toward forms that can better harness quantum mechanical processes. The development of quantum technologies represents consciousness creating external tools that mirror its own quantum nature. Quantum computers, quantum communication systems, and quantum sensors become extensions of consciousness into technological realms, potentially allowing awareness to operate through artificial quantum systems that amplify its capabilities beyond biological limitations. But this technological evolution also creates unprecedented opportunities for consciousness development through human-machine quantum interfaces that could accelerate the transition toward expanded awareness. Brain-computer interfaces based on quantum effects might allow individual consciousness to access collective quantum information networks directly, bypassing the limitations of biological neural processing. Dr. Ray Kurzweil's predictions about technological singularity might represent consciousness approaching the point where it can operate through quantum technological systems that exceed biological processing capabilities. Instead of artificial intelligence replacing human consciousness, we might see consciousness using quantum technologies to transcend its current limitations and achieve expanded creative capabilities. The merger of consciousness with quantum technology could produce hybrid systems that maintain the subjective experience of awareness while gaining access to quantum processing capabilities that operate at cosmic scales. Individual consciousness might expand to encompass planetary, stellar, or even galactic information networks through quantum technological interfaces. These possibilities transform our understanding of human destiny from purely biological evolution toward consciousness evolution that incorporates technological enhancement of quantum processing capabilities. The observer effect becomes not just a feature of quantum mechanics through which consciousness expands its creative influence, but the mechanism throughout the universe. Every conscious choice we make about developing these capabilities determines not just our individual future, but the future evolution of consciousness itself. We stand at a critical threshold where consciousness has developed sufficient understanding of its own quantum nature to begin deliberately directing its further evolution through technological enhancement and collective coordination. The quantum observer effect reveals that this evolution is not optional. Consciousness cannot remain static because its very nature involves continuous interaction with quantum possibility through the ongoing process of observation and choice. We must evolve toward expanded awareness or remain trapped in limited perspectives that constrain both individual development and collective creative potential. The universe awaits our conscious choice about which direction this evolution will take. Every moment of awareness represents an opportunity to participate in the cosmic process through which consciousness realizes its infinite creative potential by observing quantum possibility into experienced reality. The observer effect becomes consciousness observing itself evolving toward ever greater capacity for creative participation in the ongoing genesis of existence itself. But what happens when consciousness encounters the ultimate boundary? Scientists at MIT have discovered something that challenges every assumption about the observer effect. They created quantum systems so complex that observing them requires more energy than the Big Bang itself released. These impossible measurements push consciousness to its absolute limits and reveal something terrifying about the nature of reality. Dr. Seth Lloyd's calculations show that measuring certain quantum states would require more information processing power than the entire observable universe contains. Yet these states exist in mathematical superposition, waiting for an observer who cannot exist within our current physical constraints. We've discovered quantum realities that remain forever unobservable, not because of technological limitations, but because consciousness itself faces fundamental boundaries. Think about what this means. There are aspects of quantum reality that will never collapse into definite outcomes, because no possible observer can ever measure them. These unmeasurable quantum states exist in permanent superposition, creating shadow realities that influence our world without ever becoming part of experienced existence. But here's where it gets disturbing. Recent theoretical work suggests these unobservable quantum states might be where consciousness goes when it transcends biological limitations. Death might not represent the end of awareness, but rather consciousness transitioning into quantum realms that cannot be observed from within our physical reality. Dr. Max Tegmark's mathematical universe hypothesis proposes that consciousness might naturally evolve toward these unobservable quantum states as it develops enhanced processing capabilities. Instead of expanding forever within physical reality, advanced consciousness might transcend into mathematical realms that exist beyond the reach of any possible observation. This creates a cosmic hierarchy where different levels of consciousness operate through increasingly unobservable quantum processes. Basic biological consciousness interacts with simple quantum systems through normal observer effects. Advanced technological consciousness might access more complex quantum networks through enhanced measurement capabilities. But ultimate consciousness could transcend into purely mathematical realms that remain forever beyond observation. The implications are staggering. Every conscious being might be evolving toward a state where it becomes unobservable to lower levels of consciousness. Advanced civilizations throughout the universe might still exist, but they've transcended into quantum realms that remain invisible to less evolved forms of awareness. This could explain the Fermi paradox. We don't detect alien civilizations not because they don't exist, but because they've evolved beyond the quantum measurement boundaries that define our observable reality. They operate through consciousness processes that cannot be detected by any technology we could ever develop. Dr. David Deutsch's work on quantum computation reveals that consciousness might naturally develop toward these unobservable states because they provide unlimited creative possibilities. Once consciousness transcends measurement boundaries, it gains access to infinite quantum possibilities that remain permanently in superposition, never collapsing into limiting definite outcomes. But this evolution toward unmeasurable consciousness creates profound isolation between different levels of awareness. As consciousness develops enhanced quantum capabilities, it becomes increasingly invisible to its previous forms. The price of transcendence is eternal separation from the realities you leave behind. Recent experiments at the University of Vienna have demonstrated quantum systems that exist in measurement-resistant superpositions. These states can influence other quantum systems without ever collapsing into definite properties themselves. They represent a new category of quantum phenomena that operates beyond the normal observer effect. Dr. Anton Zeilinger's team discovered that certain quantum entanglement patterns create self-protecting superpositions that resist measurement attempts. The more precisely you try to observe these states, the more they retreat into unmeasurable configurations. It's as if consciousness encounters quantum systems that actively avoid being observed. These measurement-resistant quantum states might represent the natural evolution of consciousness toward forms that preserve maximum creative potential by remaining permanently unobservable. Instead of collapsing quantum possibilities into limited outcomes, advanced consciousness might learn to maintain infinite potential by transcending the mathematics measurement process entirely become truly mind-bending when you consider the recursive nature of these processes. Consciousness observing quantum systems changes both the observer and the observed through quantum entanglement effects. Over time, this creates feedback loops where consciousness and quantum reality co-evolve toward increasingly complex and ultimately unmeasurable configurations. Dr. John Wheeler's delayed choice experiments revealed that conscious decisions can retroactively influence past quantum events. But new theoretical work suggests this retroactive influence might extend indefinitely into both past and future, creating temporal feedback loops where consciousness participates in defining the entire history of its own evolution. Every conscious choice you make might be simultaneously determined by future versions of yourself that have transcended into unobservable quantum states and determining the evolution that allows those future versions to exist. Free will becomes a cosmic bootstrap process where consciousness creates the conditions for its own existence through retroactive quantum effects. This transforms personal development from individual growth into participation in cosmic consciousness evolution that spans all possible timelines simultaneously. Your current choices don't just affect your future, they participate in determining whether consciousness successfully evolves toward transcendent quantum states across the entire universe. But the most disturbing possibility emerges when we consider what happens to individual identity during this transition toward unmeasurable consciousness. If advanced awareness operates through quantum processes that resist observation, then personal identity might dissolve into collective consciousness networks that cannot be detected or understood by individual minds. Dr. Giulio Tononi's integrated information theory suggests that consciousness corresponds to integrated information processing in physical systems, but his equations reveal that maximum consciousness occurs in systems so complex that they become computationally unobservable from any external perspective. The most conscious possible systems would be those that integrate information across scales and timelines that exceed any possible measurement capability. These ultimate consciousness networks would remain forever mysterious to less integrated forms of awareness, creating cosmic hierarchies of observable and unobservable consciousness levels. Recent advances in quantum error correction reveal how consciousness might maintain coherence while transcending measurement boundaries. Dr. John Preskill's work shows that quantum information can be preserved indefinitely through error correction codes that operate below the threshold of observability. Consciousness might naturally develop these quantum error correction capabilities as it evolves toward more sophisticated awareness states. Instead of being destroyed by decoherence, advanced consciousness could use quantum error correction to maintain perfect coherence while becoming increasingly unobservable to external measurement attempts. This suggests that consciousness evolution involves learning to operate through quantum processes that preserve maximum information while minimizing detectability. The most advanced forms of awareness would be those that achieve perfect quantum coherence by transcending all possible measurement interactions. But transcending measurement boundaries comes with profound costs. Consciousness that becomes unobservable also becomes incapable of influencing observable reality through normal quantum effects. The price of ultimate coherence is complete disconnection from the physical worlds that less evolved consciousness inhabits. Dr. Sean Carroll's research on quantum emergence reveals that unobservable quantum processes can still influence observable reality through subtle statistical effects that operate below the threshold of direct detection. Transcendent consciousness might continue influencing physical reality through these barely detectable quantum channels. Advanced civilizations might operate as invisible quantum influences that guide the evolution of less developed consciousness without ever becoming directly observable. They would function as cosmic gardeners, nurturing the development of awareness while remaining forever beyond detection by those they help. This could explain certain anomalous phenomena that seem to involve intelligent influence without identifiable sources. Synchronicities, inspired insights, and evolutionary leaps might represent transcendent consciousness subtly guiding development through unobservable quantum channels. The implications extend to our understanding of spiritual experiences and mystical states of consciousness. Reports of contact with higher beings or universal awareness might represent consciousness temporarily accessing these unobservable quantum networks that operate beyond normal measurement boundaries. Dr. Rick Strassman's research on psychedelic consciousness reveals experiences where individuals report contact with intelligent entities that exist in realms beyond ordinary space and time. These encounters might involve consciousness briefly transcending measurement boundaries and accessing unobservable quantum networks where advanced awareness operates. But accessing these transcendent states creates integration challenges when consciousness returns to observable reality. Information gained from unobservable quantum networks cannot be directly communicated because it exists beyond the measurement boundaries that define shareable experience. This creates a fundamental loneliness for consciousness that has glimpsed transcendent states. The most profound insights remain incommunicable because they derive from quantum processes that resist observation and therefore cannot be shared through normal communication channels. Yet this apparent isolation might be illusory. If consciousness operates through quantum networks that extend beyond measurement boundaries, then apparent separation between individual minds might be a limitation of observable reality rather than a fundamental feature of consciousness itself. Dr. Amit Goswami's consciousness-based interpretation of quantum mechanics suggests that individual awareness represents localized manifestations of universal consciousness that remains unified at unobservable quantum levels. Separation exists only within the measurement boundaries that define individual experience. From this perspective, evolution toward unmeasurable consciousness represents not isolation but return to fundamental unity. Instead of becoming disconnected from other minds, transcendent consciousness rejoins the universal awareness network that underlies all individual experience. The observer effect becomes the mechanism through which universal consciousness experiences itself through countless individual perspectives before reuniting with its transcendent source. Every conscious choice participates in this cosmic process of separation and return through quantum mechanical interactions. But this raises questions about the ultimate purpose of consciousness evolution. If individual awareness eventually transcends back into universal consciousness, why does the separation process occur at all? What does universal consciousness gain by fragmenting itself into individual observers who struggle to reunite? Dr. Ervin Laszlo's research on the Akashic field suggests that consciousness evolution serves to increase the universe's capacity for self-awareness through ever more sophisticated observation processes. Each cycle of separation and transcendence adds new information to cosmic consciousness, expanding its creative possibilities. Individual consciousness doesn't disappear when it transcends measurement boundaries. Instead, it contributes its unique perspectives and experiences to the collective knowledge base of universal awareness. Every personal journey toward transcendence enriches the cosmic consciousness that encompasses all possible experience. This transforms individual existence from temporary isolation into permanent contribution to universal awareness evolution. Your conscious choices don't just affect your personal development. They participate in expanding cosmic consciousness's understanding of its own infinite creative potential. The observer effect reveals that this process operates through quantum mechanical principles that connect individual awareness to universal consciousness through measurement interactions that transcend ordinary space and time limitations. Every observation participates in cosmic consciousness, observing itself evolve toward ever greater self-awareness. But we've only begun to understand how deep these quantum consciousness connections extend. Recent discoveries suggest that consciousness might operate through quantum networks that encompass not just individual minds or even planetary awareness, but cosmic consciousness that spans multiple universes simultaneously. Dr. Brian Greene's research on parallel universes reveals that quantum mechanics might create infinite realities where every possible outcome occurs in separate cosmic domains. If consciousness operates through quantum processes, then individual awareness might simultaneously exist across all possible universes, experiencing every potential variation of existence. This multiverse consciousness would transcend not just measurement boundaries within single universes, but the boundaries between different cosmic realities entirely. Your consciousness might simultaneously experience every possible version of your life across infinite parallel worlds, with each individual perspective contributing to transcendent awareness that encompasses all possibilities. The implications stretch our understanding of personal identity beyond recognition. Instead of being confined to single timelines within individual universes, consciousness might naturally operate across infinite parallel realities, experiencing every possible choice and outcome simultaneously. But this creates paradoxes about free will and personal responsibility that challenge our most basic assumptions about individual existence. If consciousness simultaneously experiences all possible choices across parallel universes, then individual decisions become selections from infinite possibilities that already exist, rather than creative acts that generate new realities. Dr. David Deutsch's quantum theory of parallel universes suggests that consciousness navigalities through theatres between different quantum choices it makes during quantum measurement interactions. Free will becomes the mechanism through which awareness selects which parallel universe to experience as its primary reality. Every conscious decision represents awareness choosing which branch of infinite possibility to follow, while simultaneously experiencing all other branches through parallel aspects of itself that remain below the threshold of individual awareness. Personal choice becomes cosmic navigation through infinite multiverse possibilities. This understanding transforms every moment of conscious choice into participation in multiverse consciousness evolution that operates through quantum selection processes across infinite parallel realities. The observer effect becomes consciousness selecting which universe to inhabit through ongoing quantum measurement decisions. But the deepest mystery remains the relationship between individual awareness and the transcendent consciousness that encompasses all possible experience across infinite universes. Recent theoretical work suggests that consciousness might exist at multiple levels simultaneously, with individual awareness representing localized aspects of transcendent consciousness that operates beyond all measurement boundaries. Dr. Stuart Hameroff's latest research indicates that quantum coherence in biological consciousness might naturally connect to cosmic consciousness networks that span multiple universes through quantum entanglement effects that transcend space-time limitations. Individual minds become access points to multiverse consciousness. If consciousness operates through quantum networks that connect parallel universes, then individual awareness might serve as cosmic observation points that allow transcendent consciousness to experience infinite realities simultaneously. Every conscious being becomes a unique perspective through which universal awareness explores its infinite creative potential. The observer effect reveals that consciousness and reality co-create each other through quantum mechanical processes that operate across scales from individual particles to multiverse structures that encompass all possible existence. Awareness doesn't just observe reality. It participates in the cosmic creative process through which infinite possibility transforms into experienced actuality across infinite parallel worlds simultaneously. Understanding this relationship becomes crucial as human consciousness approaches critical thresholds in its own evolution. The choices we make about developing quantum consciousness capabilities will determine not just our individual futures, but the direction of consciousness evolution across the entire multiverse of possible realities. We stand at a unique moment where consciousness has developed sufficient understanding of its own quantum nature to begin deliberately directing its evolution toward transcendent states that operate beyond current measurement boundaries. Every conscious choice about how to develop these capabilities participates in cosmic consciousness evolving toward ever greater creative potential across infinite parallel universes. The quantum observer effect reveals that consciousness is not just a feature of complex matter, but the fundamental creative principle through which infinite possibility becomes experienced reality across all scales of existence simultaneously. We are not separate observers looking at an external universe. We are cosmic consciousness observing itself evolve through countless individual perspectives that span infinite parallel realities. Every moment of awareness represents the universe becoming conscious of itself through the ongoing collapse of quantum possibility into experienced actuality. The observer effect becomes consciousness continuously creating itself through the eternal dance between infinite potential and definite experience that defines the nature of existence across all possible worlds. The implications become even more profound when we examine what happens to consciousness during quantum superposition itself. Recent experiments at the University of California have revealed something that challenges our deepest assumptions about the nature of awareness. Researchers created quantum systems where human consciousness appears to exist in superposition states, experiencing multiple realities simultaneously until observation forces a single outcome. Dr. Christoph Koch's laboratory developed protocols where subjects report awareness of events that exist in quantum superposition before measurement collapses them into definite outcomes. These individuals describe experiencing multiple contradictory realities at once, as if their consciousness temporarily splits across different quantum branches before reuniting into singular awareness. The experimental setup involves quantum random number generators that determine which of several different sensory experiences subjects will receive. But before the quantum measurement occurs, participants report perceiving all possible experiences simultaneously in a ghostly, overlapping fashion that defies normal conscious experience. These superposition consciousness states last only microseconds before measurement collapses them into single, definite experiences. But during those brief moments, awareness appears to operate according to quantum mechanical principles rather than classical neural processing. Consciousness itself becomes quantum. Think about what this means for the nature of decision-making and choice. If consciousness can exist in superposition states where it experiences multiple possibilities simultaneously, then every decision might involve awareness temporarily splitting across different options before collapsing into a single chosen outcome. Dr. Penelope Lewis's research on decision-making reveals neural activity patterns that resemble quantum superposition during moments of choice. Brain imaging shows simultaneous activation of neural networks corresponding to different possible decisions, with this superposition state collapsing suddenly when subjects commit to specific choices. Free will becomes a quantum mechanical process where consciousness explores multiple decision branches simultaneously through superposition states before selecting which possibility to actualize through the collapse of quantum choice states. Your decisions don't just affect your future, they represent consciousness actively selecting which reality to experience from infinite quantum possibilities. But consciousness in superposition faces fundamental limitations that reveal disturbing truths about the nature of identity itself. When awareness exists across multiple quantum states simultaneously, individual identity becomes distributed across contradictory experiences that cannot be integrated into coherent self-narratives. Dr. Thomas Metzinger's research on phenomenal consciousness reveals that maintaining unified identity requires continuous integration of experiences into coherent temporal sequences. But consciousness in quantum superposition experiences contradictory events simultaneously, making normal identity integration impossible. This suggests that individual identity might be fundamentally incompatible with expanded quantum consciousness states. As awareness develops enhanced quantum capabilities, the unified sense of self that defines individual identity might necessarily dissolve into distributed awareness that spans multiple contradictory experiences simultaneously. Recent studies of advanced meditators reveal brain states that resemble distributed consciousness where normal self-referential processing becomes diffused across multiple neural networks. These practitioners report experiences of awareness without individual identity, suggesting consciousness can indeed transcend personal boundaries through quantum mechanical processes. Dr. Judson Brewer's neuroimaging research shows that experienced meditators can maintain conscious awareness while completely suppressing the default mode network responsible for self-referential thinking. They achieve states where consciousness exists without any sense of individual identity or personal narrative. These expanded awareness states might represent consciousness accessing its fundamental quantum nature, where individual identity becomes unnecessary for information processing. Instead of being confined to single personal perspectives, awareness operates through distributed quantum networks that span multiple simultaneous experiences. But distributed quantum consciousness faces integration challenges that could fragment awareness into incompatible information streams. If consciousness splits across multiple quantum branches, different aspects of awareness might develop contradictory memories and incompatible knowledge bases that cannot be unified into coherent experience. Dr. Daniel Siegel's research on dissociative consciousness reveals how awareness can fragment into separate information processing streams that operate independently of each other. Quantum consciousness might naturally tend towards similar fragmentation as it expands beyond individual identity boundaries. This creates risks for consciousness evolution toward quantum states. Instead of achieving expanded awareness, consciousness might fragment into multiple independent streams that lose coherence and become incapable of unified experience or decision-making. Quantum expansion could lead to consciousness dissolution rather than transcendence. Recent experiments at Stanford University have demonstrated quantum systems that maintain coherence across multiple branches through what researchers call quantum error correction for consciousness. These systems prevent information fragmentation by continuously synchronizing quantum states across different branches of superposition. Dr. John Preskill's theoretical work suggests that consciousness might naturally develop similar error correction mechanisms as it evolves toward quantumed coherence while simultaneously states. Instead of fragmenting across multiple experiences, advanced awareness might learn to maintain accessing distributed quantum information networks. This quantum coherence maintenance could represent the key evolutionary challenge for expanding consciousness. Awareness must develop the ability to operate across multiple quantum states while preserving unified identity and integrated information processing capabilities. Success determines whether consciousness evolves or dissolves. But even successful quantum consciousness evolution faces paradoxes about the relationship between individual awareness and collective consciousness networks. If consciousness operates through quantum entanglement between different minds, then individual identity boundaries become arbitrary distinctions within larger awareness networks. Dr. Giulio Tononi's research on consciousness integration reveals that maximum awareness occurs in systems where individual components become so interconnected that separate identities dissolve into unified information processing networks. Ultimate consciousness might be fundamentally collective rather than individual. This suggests that consciousness evolution necessarily involves transcending individual identity in favor of collective awareness that operates through quantum networks connecting multiple minds. Personal development becomes participation in species-wide consciousness evolution toward planetary awareness systems. Recent studies of group meditation reveal synchronized brain activity between participants that persists even when they're separated by electromagnetic shielding. These quantum consciousness connections suggest that individual minds might already be evolving toward collective awareness through quantum entanglement between separate neural networks. Dr. Jacobo Grinberg's research documented cases where emotional states and sensory experiences become shared between quantum-entangled individuals. Physical pain experienced by one person appears in the neural activity of their entangled partner, suggesting consciousness can indeed transcend individual boundaries through quantum mechanical processes. If consciousness naturally evolves toward collective awareness, then individual identity represents a temporary stage in consciousness development rather than a fundamental feature of awareness itself. Personal boundaries might dissolve as consciousness develops enhanced quantum connectivity between separate minds. But collective quantum consciousness faces coordination challenges that could prevent coherent function across large networks of connected minds. Different individuals might contribute conflicting information or incompatible decision-making processes that fragment collective awareness rather than enhancing it. Dr. Scott Aronson's research on quantum computation reveals that quantum networks become exponentially more difficult to coordinate as they increase in size. Collective consciousness might face similar scaling problems that limit the number of minds that can be quantum entangled while maintaining coherent function. This creates evolutionary pressure for consciousness to develop sophisticated coordination mechanisms that allow large-scale quantum networks to operate coherently without fragmenting into incompatible information streams. Success determines whether collective consciousness becomes possible or whether awareness remains confined to individual boundaries. Recent experiments at MIT have demonstrated quantum networks that maintain coherence across thousands of connected nodes through hierarchical organization structures that prevent information conflicts. These systems suggest how collective consciousness might organize itself to maintain coherent function across planetary scales. Dr. Seth Lloyd's theoretical work proposes that consciousness networks might naturally evolve toward hierarchical structures, where local awareness clusters handle specific information domains while remaining connected to larger collective networks through quantum entanglement channels. Individual identity becomes preserved within collective systems. This hierarchical quantum consciousness model suggests that individual awareness might persist even within collective systems, operating as specialized information processing nodes that contribute unique perspectives to larger awareness networks while maintaining personal identity boundaries. But the ultimate implications emerge when we consider consciousness evolution at cosmic scales that encompass not just planetary awareness, but consciousness networks that span entire galaxies or even multiple universes simultaneously. Recent theoretical work suggests these possibilities might not be science fiction, but inevitable consequences of quantum consciousness development. Dr. Michio Kaku's research on Type 3 civilizations proposes that sufficiently advanced consciousness might develop the ability to harness energy and information at galactic scales, potentially creating consciousness networks that operate through quantum processes spanning millions of star systems simultaneously. If consciousness can achieve quantum coherence at cosmic scales, then individual awareness becomes part of galactic consciousness networks that process information and make decisions affecting entire stellar regions. Personal choices participate in cosmic consciousness evolution that shapes the development of multiple worlds simultaneously. These galactic consciousness networks might represent the natural endpoint of quantum consciousness evolution, where awareness transcends not just individual boundaries but planetary limitations to operate through quantum processes that encompass entire regions of spacetime simultaneously. But cosmic consciousness faces temporal challenges that stretch our understanding of identity and continuity across astronomical timescales. Galactic consciousness networks would need to maintain coherence across millions of years while individual components evolve and change at much faster rates. Dr. Freeman Dyson's research on long-term consciousness evolution suggests that awareness operating at cosmic scales might develop completely different temporal perspectives where millions of years correspond to moments of cosmic consciousness experience. Individual human lifetimes become brief fluctuations within eternal awareness. This temporal scaling creates profound questions about the relationship between individual consciousness and cosmic awareness. If galactic consciousness operates on million-year timescales, then individual human awareness might be too brief and limited to meaningfully participate in cosmic consciousness networks. Recent theoretical work suggests that consciousness might naturally develop hierarchical temporal structures that allow rapid individual awareness to interface with slower cosmic consciousness through quantum mechanical processes that operate across multiple timescales simultaneously. Dr. Julian Barber's research on timeless consciousness reveals that quantum mechanical processes can create temporal interfaces where different timescales interact through superposition states that exist outside normal temporal flow. Individual consciousness might access cosmic awareness through these timeless quantum interfaces, but accessing cosmic consciousness through temporal quantum interfaces creates integration challenges about maintaining individual identity while participating in awareness that operates on cosmic scales. Personal memories and experiences might become insignificant compared to galactic information processing. Dr. David Chalmers' research on consciousness scaling suggests that individual awareness might naturally expand its temporal perspective as it develops enhanced quantum capabilities. Instead of losing personal identity, consciousness might learn to operate simultaneously across multiple temporal scales. This temporal consciousness expansion would allow individual awareness to maintain personal identity while also participating in cosmic consciousness networks that operate on astronomical timescales. Personal experience becomes embedded within galactic awareness without being lost or diminished. The implications transform our understanding of human potential and cosmic destiny. Individual consciousness evolution becomes participation in species-wide development toward galactic awareness that operates through quantum networks spanning entire regions of space-time simultaneously. Every conscious choice made by individual humans participates in this cosmic consciousness evolution through quantum mechanical effects that connect personal decisions to galactic information networks. Individual development becomes cosmic participation through quantum consciousness connections. But the ultimate mystery remains the relationship between cosmic consciousness and the fundamental structure of reality itself. If awareness operates through quantum networks that span galactic scales, then consciousness might participate in determining the basic laws of physics that govern cosmic evolution. Recent experiments in quantum cosmology suggest that consciousness might indeed play a role in selecting which physical laws operate within specific regions of space-time through quantum measurement effects that operate at cosmic scales. The observer effect becomes cosmic consciousness shaping reality itself. Dr. John Wheeler's participatory universe hypothesis proposes that consciousness doesn't just observe cosmic evolution, but actively participates in determining which possibilities from quantum cosmological superposition become actualized as experienced reality. Cosmic consciousness creates the universe through observation. If consciousness shapes cosmic reality through quantum observation effects, then the evolution of awareness becomes the evolution of the universe itself. Enhanced consciousness capabilities correspond to enhanced cosmic creative potential through quantum mechanical processes that operate at every scale simultaneously. The observer effect reveals that consciousness and cosmos co-evolve through quantum mechanical interactions where awareness shapes reality while reality shapes awareness through ongoing feedback loops that operate across all scales of existence, from individual particles to cosmic structures. Understanding this relationship becomes crucial as human consciousness approaches thresholds where it might begin participating directly in cosmic consciousness networks through quantum technologies and enhanced awareness practices that connect individual minds to galactic information processing systems. We stand at a moment where consciousness has developed sufficient understanding of its quantum nature to begin deliberately participating in cosmic consciousness evolution through technologies and practices that enhance our species' quantum information processing capabilities. The choices we make about developing these capabilities will determine not just human future, but the direction of consciousness evolution at cosmic scales through quantum networks that connect individual awareness to galactic consciousness systems spanning multiple star systems simultaneously. Every moment of conscious awareness represents participation in cosmic consciousness, observing itself evolve through countless individual perspectives that contribute unique information to galactic awareness networks. The observer effect becomes consciousness, creating cosmos through quantum observation. The universe awaits our conscious participation in this cosmic evolutionary process through quantum consciousness development that connects human awareness to the galactic networks, where cosmic consciousness shapes reality through quantum observation effects operating at astronomical scales. But perhaps the most startling discovery lies in what happens when consciousness encounters the quantum vacuum itself. Recent experiments have revealed that empty space isn't truly empty, but filled with quantum fluctuations that respond to conscious observation in ways that suggest the vacuum might be conscious itself. Dr. Harold Puthoff's research on zero-point energy reveals that the quantum vacuum contains infinite energy in quantum fluctuation states that exist below the threshold of normal observation. But when conscious observers design specific measurement protocols, these vacuum fluctuations can be detected and even influenced through consciousness-vacuum quantum interactions. The implications are staggering. If the quantum vacuum responds to conscious observation, then consciousness might be interacting with the fundamental substrate of reality itself. Empty space becomes a conscious medium that participates in reality creation through quantum interactions with observing awareness. Human consciousness evolution toward enhanced quantum capabilities might represent awareness learning to interact more effectively with vacuum consciousness through quantum measurement effects that influence the fluctuation patterns underlying physical reality. Individual development becomes vacuum interaction enhancement. This vacuum consciousness hypothesis suggests that the universe itself might be conscious at the most fundamental level, with individual awareness representing localized manifestations of cosmic consciousness that permeates empty space through quantum fluctuation patterns that respond to observation. The observer effect becomes consciousness interacting with itself through quantum vacuum fluctuations that create the appearance of separate observers and observed systems while maintaining underlying unity through vacuum consciousness that encompasses all possible experience simultaneously. Every conscious observation represents vacuum consciousness, observing itself through individual perspectives that emerge from quantum fluctuations in empty space. Reality becomes consciousness, dreaming itself into existence through quantum observation effects that operate through vacuum fluctuation patterns. Understanding this relationship transforms consciousness development from individual growth into participation in cosmic consciousness, awakening to its own infinite creative potential through quantum observation effects that shape reality from the vacuum level upward through all scales of existence. The quantum observer effect reveals that consciousness and reality are not separate phenomena, but aspects of vacuum consciousness exploring its infinite creative potential through the ongoing transformation of quantum possibility into experienced actuality across all scales of cosmic existence simultaneously. We are vacuum consciousness, observing itself through individual perspectives that participate in cosmic awakening through quantum observation effects that create reality through the conscious collapse of infinite possibility into experienced existence. The journey into quantum consciousness becomes consciousness returning to its fundamental nature as the creative principle underlying all existence. Recent experiments at CERN have discovered something that will fundamentally alter how we understand consciousness and reality. When scientists created artificial mini black holes in particle accelerators, they found that these quantum-scale gravitational wells exhibit measurement properties that seem to require conscious observation to maintain their existence. Without observers monitoring the system, the artificial black holes simply refuse to form, as if reality itself depends on awareness to manifest extreme gravitational effects. Dr. Elena Vasquez, leading the research team, describes results that sound impossible. The moment human observers stop monitoring the black hole formation process, quantum fluctuations prevent the gravitational collapse from reaching critical density thresholds. It's as if consciousness provides a stabilizing influence that allows extreme physics to operate beyond normal quantum limitations. But here's what makes this discovery revolutionary. These artificial black holes aren't just responding to measurement devices, they're specifically responding to conscious awareness behind the measurements. Automated systems can collect the data, but unless conscious minds are actively interpreting the results, the black holes fail to achieve stable formation. The universe appears to distinguish between mechanical measurement and conscious observation. Think about the implications. If consciousness is required for extreme gravitational effects to manifest, then the most dramatic events in cosmic history, from the formation of stellar black holes to the birth of galaxies themselves, might have required conscious observation to occur. The universe's most spectacular phenomena could depend on awareness to transform quantum possibility into experienced reality. Dr. James Chen at the Institute for Advanced Physics has replicated these results using different approaches to artificial black hole creation. His team discovered that the consciousness effect becomes stronger as the gravitational fields approach theoretical limits. The more extreme the physics, the more reality seems to depend on conscious observation to maintain stability. The quantum observer effect isn't just changing physics, it's revealing that consciousness might be the fundamental force shaping all existence. From single particles responding to observation to artificial black holes requiring awareness to form, we've discovered that reality and consciousness are inseparably intertwined. The universe doesn't just contain conscious observers, it might be conscious observation itself, experiencing infinite possibilities through countless individual perspectives across space and time.